In the age of hypersonic missiles and autonomous drones, warfare has entered a new and uncharted frontier. Among the most awe-inspiring and now shelved innovations in modern military history is the U.S. Navy's electromagnetic railgun, a weapon so powerful it didn't need gunpowder or explosives to inflict catastrophic damage. Instead, it relied solely on kinetic energy, pure, blistering speed, and a block of metal. For over a decade, the railgun stood as a shining emblem of next-generation warfare, but in a stunning turn, this revolutionary weapon vanished quietly from development. Why did the Navy pull the plug on such a powerful machine? And what futuristic alternative rose in its place? Let's take a closer look at one of the most ambitious weapons projects in American history and the laser revolution that may change warfare forever. The electromagnetic marvel that promised to rewrite naval combat. Developed at the Naval Surface Warfare Center, the railgun was anything but ordinary. Imagine a cannon that didn't fire explosives, but instead launched solid steel projectiles at over 8,000 feet per second, more than Mach 7. That's 5 times faster than a standard rifle bullet. At these speeds, even a 7-pound slug of metal could rip through ships, fortifications, or aircraft like paper, delivering the destructive power of a small artillery shell without a single ounce of explosive. The railgun was powered by electromagnetic forces generated by massive electrical currents that ran through 2 parallel rails. When fired, the energy from these capacitors accelerated a projectile almost instantly to hypersonic speeds. The result? A weapon with a range over 100 miles, capable of striking with terrifying precision and force. In its early test phase, the Navy achieved impressive results with an 8 megajoule prototype, enough to obliterate targets with ease. But their true goal was even more ambitious, a 64 megajoule monster designed specifically for future warships. This weapon could, in theory, outmatch traditional naval guns by every metric: no gunpowder, no explosive shells, no stockpiled munitions. Instead, warships would carry safer, inert projectiles and rely on electricity alone to destroy targets. With such capabilities, naval warfare would never be the same. Why the railgun failed to launch? But as tests continued, so too did the challenges, and they proved too formidable. Each railgun shot consumed an incredible amount of electricity, as much as what's needed to power multiple city blocks. The wear and tear on the rails was extreme. They eroded quickly due to the intense heat and electromagnetic stress. After only a few firings, components had to be replaced, and cooling the weapon became a persistent problem. Shipboard integration proved especially problematic, since most current naval vessels couldn't generate or store enough energy to operate the gun reliably. The Navy had invested over $500 million in the railgun program. Yet, in 2021, after years of testing, the project was quietly shelved. No grand announcement, no public debate, just a strategic pivot toward other technologies, specifically hypersonic missiles and directed energy weapons, from steel slugs to beams of light. As the railgun faded, another once sci-fi weapon quietly took center stage: the naval laser. Where the railgun relied on brute force, the laser embodies surgical precision and silent lethality. On May 16, 2020, aboard the U.S. Portland, the U.S. Navy made history by successfully testing a solid-state laser weapon system at sea. Its first target? A drone flying above the ship, which was swiftly disabled without a single explosion. The laser beam, invisible to the eye, silently overheated and fried the drone's electronics, sending it crashing into the ocean like a toy. Unlike the railgun, the laser weapon has no moving projectiles, no recoil, and no need to reload. It engages targets by focusing energy into a single point, delivering heat so intense that it can disable sensors, blind optics, burn through metal, or destroy engines. Why lasers may be the future of naval warfare. What makes lasers especially promising is their operational efficiency. Each shot costs approximately $1 in electricity, compared to the millions spent on interceptor missiles. That's a game-changing economic shift. Lasers can also engage multiple threats at once, shifting between targets nearly instantly. And while the railgun needed futuristic power systems to operate, modern warships already generate enough electricity to support laser operations without sacrificing other capabilities. Though heat management remains a challenge, engineers have devised cooling systems that allow extended use during combat. The implications are massive. Swarm attacks from enemy drones. Lasers can knock them out of the sky in seconds. Small enemy boats. Their engines can be disabled without destroying the vessel. A useful option when total annihilation isn't the goal. Why lasers make more strategic sense? From a strategic standpoint, the Navy's pivot toward lasers aligns with both cost-effectiveness and battlefield control. Where missiles and traditional guns rely on finite ammunition, laser systems have essentially unlimited shots, as long as the power holds out. Lasers also introduce a non-lethal option in scenarios where disabling a threat is preferable to sinking it. In congested sea lanes or near civilian areas, this flexibility matters. Critically, lasers provide speed-of-light defense against aerial threats. That means drones, missiles, or even fast-moving aircraft have almost no time to evade once targeted. Traditional countermeasures become useless when the weapon system engages at the speed of physics itself. The heavy hitters still rule, for now. Yet for all the promise of directed energy, raw explosive firepower still dominates naval strike capability. Take the Tomahawk land attack missile, a long-range cruise missile capable of reaching targets over 1,000 miles away. Stored vertically in launch cells, these missiles carry massive explosive payloads and sophisticated terrain-matching guidance systems. Once launched, they fly low and slow, skimming terrain to avoid detection before slamming into high-value targets deep inland. Similarly, the Navy's Mark 54 torpedoes, loaded with Torpex, an explosive 50% more powerful than TNT, can hunt submarines with ruthless efficiency. Guided by sonar and capable of distinguishing targets, they remain a critical part of the Navy's underwater arsenal. Rearming at sea, a dangerous necessity. But these weapons come with logistical dangers, particularly when it comes to rearming at sea. Unlike in calm harbors, where cranes can methodically reload vertical launch systems, open ocean conditions make this process extraordinarily dangerous. A single misstep when moving a half-ton missile on a rolling deck could result in disaster. The Navy has, in fact, removed most shipboard cranes after fatal accidents, further complicating at-sea reloads. Still, with rising tensions in the Indo-Pacific, the Navy is once again training for these high-risk operations, acknowledging that extended deployments may require reloading while far from friendly shores. How the Navy survives modern missile attacks. Modern naval defense depends on layered systems. Long before an enemy missile reaches a ship, the U.S. Navy deploys tools like the Naval Strike Missile, capable of engaging enemy vessels 345 miles away with surgical accuracy. If those fail, ship-based platforms like High Mobility Artillery Rocket System, adapted for sea use, can deliver guided rocket fire to intercept landing forces or missile platforms. But the final line of defense, the Phalanx Sea Whiz, is where things get truly dramatic. This automated Gatling gun fires up to 4,500 rounds per minute, creating a metal storm capable of shredding incoming missiles. Fully autonomous, it detects, tracks, and engages targets within a 5-mile radius, often within seconds of impact. Its tungsten rounds can detonate warheads mid-air, protecting ships from catastrophic damage. And it all happens without any human intervention, a necessity when missiles travel at Mach 3, giving defenders less than 10 seconds to respond. F-35 fighters and the future of aerial warfare. Finally, soaring above the waves, sits the most advanced naval platform of all, the F-35 Lightning II. This fifth-generation stealth fighter, deployed from carriers like the United States ship Gerald R. Ford, combines radar-evading design, high-tech sensors, and AI-powered combat systems. Each F-35 can engage multiple targets over 100 miles away, while remaining virtually invisible to radar. Its onboard computers can identify, track, and strike threats faster than human pilots can think, often autonomously recommending or executing attacks. And with guided bombs, air-to-air missiles, and electronic warfare packages, each fighter becomes a flying arsenal capable of reshaping entire battle spaces. Thanks for watching. If you found this deep dive into the future of naval warfare fascinating, from railguns to laser weapons and stealth fighters, don't forget to give this video a thumbs up and subscribe.